Bismillahirrahmanirrahim. Today lecture is generative function. There are three types of generative function. We can generate the function in three types. The first generative function designed to calculate the moment. First is the moment generative function, and it is denoted by shortly MGF. The second method of generative function is cumulative generative function, and third is the probability generative function. Now we discuss first method, the moment generative function. Let a random variable x have the PDF f of x. The moment generative function is denoted by the moment generative function is denoted by mx of t, and this is the definition of moment generative function. Expected value of e raised power tx. This is the definition of moment generative function. This is the basic definition of moment generative function. And what is the benefit of the moment generative function? We can generate the moments from this function. We can find the mean, we can find the variance, and we can find the sequence, the shape of the distribution, and we can find the kurtosis. This is the moment generative function help to find the shape of the distribution. The moment generative function, there are two types, continuous distribution and discrete distribution. By definition of moment generative function, mfx of t, expected value of e raised power tx. This is the continuous function, and this is the for discrete function. For continuous function, minus infinity to infinity e raised power tx f of x. This is the definition of expected value of x, the definition of expectation. And this is the discrete. For discrete is the expectation of the sum of a varies from 1 to n e raised power tx f of x. Now this is the definition of moment generative function for continuous and for discrete. The integration or summation being extended to the entire range of x, t being the real parameter, and it is being assumed that right hand side of a it is absolutely convergent for the same positive number, and such that minus h less than t and less than h. Thus this is the definition of moment generative function m of x of t, and this is the expected value of e raised power tx, and this is the expectation. And the exponential function e raised power, this is the series. This is the definition of e raised power tx, 1 plus x square over 2 factorial and so on t x power r over r factorial. This is the definition of exponent of power tx. And now apply the inside the expectation. This one is the constant and not affect any expectation, plus t is the constant and expected value apply on the variable x, expected value of x, plus t square over 2 factorial, and expectation apply on the x square, expected value of x square, and so on t power r factorial. This is the constant considered, expected value of apply on x r. This is the expected. And now what is that is? This is the moment about origin, first moment about origin, and this is the second moment about origin, and so on. This is the rth moment about the origin. Now I put the here expected value of x is the first moment of about origin, mu1 prime and mu2 prime and so on, mu r prime, and we can write the r varies from 0 to infinity t r over r factorial. And this is the another definition of moment generative function about origin and r, where mu r is equal to expected value of r. This is for continuous and for discrete. This is the rth moment of x about origin. Thus we see that the original coefficient of tx tr r factorial in mx of t gives mu r times about origin. Since m of x of origin is the moment, it is known as the moment generative function. Now for moments we differentiating b with respect to r times and putting t is equal to 0, and we get. Now this is the we differentiate r times because we find the rth moment. For rth moment we need to do the derivative of moment generative function. If we first moment, then this is the equal to the mu1 prime, second moment, second derivative of m of x of t, then this is denoted by second moment mu2 prime. In general, the moment generating function x about the point x is equal to a is defined as m of r of t about x is equal to a expected value of expected e raised power t or into x minus a. And we can write the this a exponent of e raised power t x minus a. We can write this is the infinite series, and mu1 prime mu2 prime, this is the mu1 prime about any arbitrary point a. This is the rth moment expected value of x minus r is power r is the r moment about the point x is equal to a. And now we find the m of x minus a of t expected value of e t x minus a, and we can write this form e power tx and e raised power minus at, and this is the constant e to outside e minus a, and expectation apply on that e raised power tx. And this, what is this? This is the moment generating function, and this is the also moment generating function. Now I will discuss the question about moment generating function. The question is that let x be a random variable with probability mass function pmf, and this is the function probability of x is equal to small x p q power x minus a, and p is equal to 1, q is equal to 1 minus p. Find the mgf, the moment generating function, and hence find first four moment about the origin and mean. We want to find about origin moment mu1 prime, mu2 prime, mu3 prime, and mu4 prime, and also we find mean. First we find the moment generating function, and this is the definition of moment generating function. This is the definition of moment generating function. Moment generating function, an expected value of expectation of e t of x sum of, this is the discrete distribution. Now I will apply the summation x x varies from 1 to infinity e power dx, probability of x is equal to a, and this is the expected probability of x is the p q x minus a. We put the here x is equal to I varies from 1 to infinity. This is the definition, and you can see that we write here q power x and q power minus 1, and this e raised power tx and q power x we can write combine here, and p over, this is the minus 1 inside outside the over p over q, x varies from 1 to infinity, and this is the x power, and this is the series infinite series. I apply the x varies from 1 to, first we apply 1 e raised power t q into 1, and plus 2 plus e raised power 2, and apply the 3, and this is the series apply here. And we take common e raised power t and q, and all terms are common, and in outside, then inside the in the bracket 1 plus e power t raised power t q plus e raised power t q square, and so on. We can write here this form is the in series, and we can write here right side 1 minus x power minus 1 is equal to 1 plus x square. This is the binomial expansion we write here, and this is the moment generating function of x of t. This is the moment generating function. Now I want to find the moments about origin mu1 prime, mu2 prime. Then we want to find, if we want to find mu1 prime, then we need to the derivative of moment generating function. We take derivative with respect to t of moment generating function, then this is the d over dt of this function moment generating function. This is the division rule apply here for derivative. This is the, and for calculation we you can look at this moment generating function of this derivative. This is the mu1 prime p into e raised power t 1 minus e raised power t of q whole square. Okay, now I want to put t is equal to 0 for mu1 prime. T is equal to 0, e raised power 0 is equal to 1 minus e raised power 0 q whole square. This is the first moment mu1 prime about origin. Now I want to find the second moment about origin, then with second derivative of this function about with respect to t. This is the mu1 prime 1 over p, and for the second moment, this is the second derivative of moment generating function. The second derivative moment generative function, this is the put here all the derivative of this function. This function is this term is for derivative of second time derivative of moment generative function. You can do the all calculations mu2 prime. Now the mu2 prime is this side, p is power t into 1 plus e raised power t q, or over 1 minus e raised power t q power 3. Now want to put that t is equal to 0 for mu2 prime. This is the for 2 prime, this is the value of second moment about origin, 1 over q over p square. Now you can find the for third moment about origin. We take the derivative of 3 times of moment generative function, 3 times of moment generative function, then we put t is equal to 0. This is the very large calculation of the for this function. You can take small values of this function. Mu 3 prime of this is the value of mu 3 prime. We put t is equal to 0, then we take this is the mu 3 prime, this value q1 plus over 3 or mu power 3 p power 3, and mu for fourth moment about a prime moment about a region for fourth time derivative of moment generative function. This calculation of you can do the all calculation. Put t is equal to 0 for fourth moment about a region. This value is the now this value is the moment fourth moment about this value moment generative function. Now I want to find the mean. Mean is equal to mu1 prime 1 over p. Now find the variance. Variance is the definition of variance of moment. Mu2 prime minus mu1 prime whole square. Now what is the value of the mu second prime moment? 1 q or 1 plus q over p square minus this is the mean of 1 over p square. And now the for after calculation q is 1 over p square. Now you and here we will learn about the moment generative functions and how to find the moments, prime moments and the mean moments. If we want to mean moments, so you can put the values in the relation of the moments, raw moments and mean moments. Thank you very much.